All right, Aqua Gang, in this video, we're gonna cover what a Matroid is. Hopefully you don't know and you'll learn. I've been on a hiatus, been going to school and shit. What's up? No, like, longest whatever. This is a fucking real video. I'm gonna edit it and shit. 13 minutes, okay? Let's do this. Okay, let's start off here. So I wrote this down. I got a fucking crazy ass setup right now. Got like books stacked up and my phone is on like the side of recording this shit. So what are Matroids? The topic, that's the topic of this video, I guess. And we're gonna like do like maybe like 3 problems from my math midterm. So I took a class last semester called Groups and Geometries at my college. Groups and Geometries. So this is supposed to be a class about groups and geometries, except the fucking professor just made about Matroids. So, but again, the question, what are Matroids? Matroids, let's say, are a mathematical structure or some shit. A mathematical structure. How do you spell structure? Like this, I think. To bridge different areas of math. Areas of math combinatorially. Okay, yeah. So, yeah. So, what the fuck does this mean? So, we can start by just kind of saying, like, we have a set. So, for those of you that don't know, a set, we just say is, like, a group of objects. Why not, you know? So we have a square, a circle, and a triangle. And let's say this is a set. And inside the set, there's a square, a circle, and a triangle. That's it. Okay, now they know what a set is. This is a set. Yeah, fuck it, a set. Now we can do some cool shit. Let me not do that. This is my first time ever doing something like this. So we know this now. Okay, so now we introduce these concepts of a ground set and an independent set. So you know what a set is now, right? It's just a group of objects. So it can even be like 1, 2, 3, and so on up to infinity. Let's say, fuck it, just a big ass number that we can't think of. Usually you don't write it like this. Fucking math people don't like you writing, but just for me explaining it to you, we'll write it like that. So yeah, so now you know that a set is, let's say, a ground set and an independent set. These are just both sets. But in Matroid theory, now we're actually going to learn about Matroids. In Matroid theory, there's this concept of a set, which is denoted usually by E, and then an independent set, which is just denoted by I usually. And we say that a Matroid, well, they're actually fine. Let me note. There's a lot of definitions for Matroids. So yeah. Let me write that fast. I mean, actually, I can just speed it up now and fucking the editing.
Lots of defs for Matroids. This is short for definitions.
Okay. So we say a Matroid is defined. This says, what are we defining? We're defining. So these colons mean we're defining. You already know what the fuck it means. So we say a Matroid is a structure of a ground set. Okay, a ground set and an independent set, which we'll denote as this. And inside of like this thing, there are these fucking eyes, the eyes. Okay, cool. And note that I didn't write this thing as with the curly brackets, so not like one of these. I wrote it just with this. Yeah. Because it's a structure, it's not a set. Okay, cool. Okay, so let's do an example now of what a fucking Matroid is. Okay, so when I learned about Matroids, a common like Matroid is the uniform Matroid. So what is the uniform Matroid? Well, the uniform Matroid is just this. It's just that. So we have a U and a 2 and a 4 as the subscripts. So this 2 and 4 just mean that the 4 means that in the ground set of this, we have 4 elements. So we'll just write it like this. okay? And in E, we can just say A, B, C, D. Cool. And in I, so note that the 4 just means that there's 4 elements in the ground set, like I said, I think. And now the 2 just means that any combination of these elements, so objects in a set are called elements. So any 2 of these elements or objects in this set are in independent set. Okay, cool. So we have, or at most any 2. So we have first just A, B, C, D are all independent sets. And we also have a B, a C, a D, and so on, you know. So BC, BD, fucking CD, I guess. And note, like, we don't repeat, like, so I could say, like, maybe a fucking CA, but we already have AC, so, you know, we don't write that. Cool. And that's all the independent sets. Sick. Yeah. So I'm filming this part of the video now, like a week and a half after from the last part. I got a bit too excited, I guess, from the last part. If you know what I mean. So last time, I guess, we were going over, like, what the fuck? Oh, fuck that shit. We went over, like, what a uniform Matroid is, and honestly, that was a bad example. Like, also, just note that this 2 and 4 can be any number, and it still stands on everything else that I said. Okay, but what is a Matroid generally? I think is what I want to get down. Like, so, you know, I went over, like, that it's a mathematical structure, right, that has some, like, bullshit. Mathematical structure to bridge different areas of math combinatorially. And that's definitely correct. That's definitely correct, because with this ground set and independent set, you can really, like, make any objects from different areas of math into the ground set, and then this notion of independence kind of, like, stands for everything. So if you want to, like, just write if you want to, like, say that a ground set and an independent set is a Matroid, then it has to satisfy these 3 things. First, the independent set cannot be empty, okay? Second, this says that, like, a set is just empty. This is the set, and it cannot be this. It cannot be this. Second, if you have an element, so an element, let's say J in I, so note this is a set, J is a set, and, oh fuck, the light's a bit too bright, my fault, and this is gonna get a bit complicated, just, like, bear with me. Let's say G is inside of J, so all the elements of G are also inside of J, then G is also in I. Okay, this is a bit tricky, but just, you know, 2 minutes, holy fuck. Okay, third, if you have 2 things, like, let's say again, J and G in I, right, in curly I, so the independent set, and J, fuck it, wait, don't. Let's say G is smaller, strictly smaller than J, right? So this is saying how many elements are in G, how many elements are in J. The amount of elements in G is less than J. Then, oh fuck, there exists some element in J such that, we're gonna say such that if you add this element, let's say X, so this element, there exists some element in J such that, so element, and fuck, okay, I'm dog shit at this, fucking 3 minutes, okay, element in J, or yeah, X inside of J, then you can add this element, let's say just, fuck you fucking mathematicians, motherfuckers, you can just add this shit to G, and this will still be in I. Now, this is a bit fucking crazy if you just kind of, like, bear with me. And if it satisfies these 3 things, the independent set cannot be empty. Second, if you have fucking an independent set, then any subset of that independent set must be it must be an independent set, like which we can see this uniform matrix kind of satisfies. And thirdly, if you have two independent sets, right? So this just says that they're both independent sets, and G is a smaller, so it has less elements than the other independent set J. Then there exists some element in J that when you add it to the smaller set, it will still be an independent set. Cool. If it does those three things, then it is an independent set. Okay, so I was a bit too excited in the last clip. I was talking a bit too fast and shit, and I ended off by saying that if it satisfies the three qualities, then it's an independent set. I meant to say it's a matroid. Yeah, not an independent set. Also, like, note that the curly I is the set of sets, or the set of independent sets. That kind of clears things up, I think, too. And also note that the X in this kind of third kind of rule, oh shit, or yeah, the third, so this third rule, the X, it can, so we said it's an element in J. Note that it's an element in J, yeah, but it cannot be in G. So it's X is an element in J, not in G. Cool. And okay, so we want to have this vibe for independence to be any quality in math, right? So in linear algebra, we have this notion of linear independence. So if you have three vectors, okay, and when I'm saying this shit, like, you know, just kind of like your intuition for it is probably correct. So go with it, okay? And so linear independence, so it's just this notion of independence again, like we've always been talking about. And in linear algebra, you have these things called vectors, which they're just objects like in a set, like we've been saying. And these elements are independent if you add them up like this, and A, B, and C are just numbers. We call them constants, I guess, because they can't be variables. Fuck it. And this is these vectors are independent of each other if it satisfies this only when A, B, and C are 0. So that's like some math. Fuck it, you know? This is a fucking math video, you know? Deal with it. And another kind of like vibe for independence is this kind of quality of graph acyclicity. But yeah, so if you have like a graph is just like, oh my god, you have like a fucking circle here and another circle here, and you connect them. Congratulations, you have a graph. Now if you have another one over here, and you draw another circle, or a fucking line, then it's still a graph. If you connect it like this, it's still a graph. It's just dots connected with lines. You don't have to fucking be too deep about it. And so graph acyclicity, I wrote all the acyclic, like, kind of like paths that you can take, but it's acyclic if like you say like going from here to here to here and back, that is a cycle. So an a cycle, so not a cycle, would just be all of these. So just 1 is not a cycle, 2 is not a cycle, 3 is not a cycle, 4 is not a cycle, 1, 2 is not a cycle. Note that I didn't write 1, 3 because you can't really have a cycle like that. 1, 4 is a cycle, 2, 3 is a, yeah, fucking so on. So these are all cycles. Cool. Okay, so now hopefully that we have a kind of vibe for what independence is. I'll go through one problem for my midterm, and this video is not 13 minutes. Hopefully I can fucking cut out some shit. I don't fucking know. So yeah, so this is my midterm. So question 1 was let M, so the matroid, be the structure of E, the ground set, as we know, and this fucking weird thing C, okay, we'll come back to that later, be the matroid on the ground set E, okay, cool, E is A, B, C, D, E, whose circuits are, oh, circuits, this C is a circuit, and the circuits are this. Note that a circuit is a set, right, where if you delete, so if you like get rid of one of the elements in a circuit, then the set becomes independent. So yeah, so define this as this is a circuit. So circuits are defined as sets where if you delete an element, you get an independent set. An independent set. Cool, that's it. So we can go back to the question. And so this is one, and then obviously there's a part A. So A is sketch M as a representable matroid, i.e. draw the vectors. That's it. A representable matroid is just like a visualization of the matroid, which in this case we can visualize them as vectors, which I went over like from the vibe of linear independence. This is these are vectors. So vectors, like I said, they're elements, they're just elements. They're just elements. And I even noted circuits are minimal dependent sets, so that's just a fancy way to say this. So sets where if you delete an element, you get an independent set. So cool. So we have A, B, C, D, E. So, and we can do an example. So a representable matroid here would be like if you draw the 3D thing, you get A in one, B in another. Wait, hold on. Let me think. Okay, I had written here a D. I did not mean to write that. So, right. So if we want to just like sketch this, we want to say that this AB, if we delete A or B, it will be independent. So if we have this like this, that holds true. Because A and B, they're pointing in the same direction. So you can create B from A or or A from B, you know? And from this example, like you could, so in vectors, you could like mirror A to be like in this direction. And when you add B and A together, so B is 2, 0, 0. Okay, so this is now being filmed about a month later. I've done a lot of other shit between that time and now, but so I've rewatched like every single fucking clip I have fucking recorded so far, and especially this last clip that I recorded. I want to note that A, B, C, D, E are all vectors, and they correspond to A being this vector, so 1, 0, 0, B being 2, 0, 0, and so on. And doing some math, like so we want to prove that this example satisfies this these circuits for this matroid. So AB is a circuit because if we remove A or B, then the resulting set of A or B is independent. And same thing goes for all the other ones. Fuck, I'm kind of rusty. It is 2 a.m. B, D, E, let's just check that one. B, D, E, let's remove D. So now we have the set of B and E. Note that I've been saying like this is a set, even though I'm not wrapping around the curly brackets. I'm kind of fucking stupid for that, but that's just how like in matroid theory kind of how the shit works. I don't know. So yeah, these are all sets within this set. Yeah, whatever. If we delete, what the fuck was I saying, D from B, D, E, B, E would still be independent because there's no combination. So if we have like a constant, let's say x1 on B plus x2 on E, there is no constants x1 or x2 which you can come up with to make this equal 0 other than x1 and x2 being equal to 0. So that's the only way it could be 0, because B only has a number in this kind of like a row, and E has numbers in 2 rows. So there's no way you can make it 0, you know? You can also look at that visually. B is pointing in that direction, and E is pointing in a combination of that direction and this direction. So, you know, you can't really delete E from just using B. Hopefully that makes sense. I also wrote this, if this makes any sense. These dependent sets of vectors means that a linear combination of them has coefficients multiplying each vector that are not all 0, and still the linear combination is 0, i.e. there is non-trivial coefficients to make the linear combination 0 for these circuits. Hope that makes sense. If you have any questions, leave in the fucking comments, motherfuckers. Sketch M as graphic matroid. Sure, okay. So for this question, note that the circuits again are A, B, C, D, A, C, E, A, D, E, B, C, E, and lastly B, D, E. So I'll just go through case by case instead of what the fucking debacle was for the last part for this question. So for A, B, we have a circuit, or we have a we have a circuit. Yes, we have a circuit. A, B is a circuit because if you follow A and then B, you fall back onto the same like point. So you know, like it forms a path. It forms a closed path. I mean, so if you delete either one of them, then you don't have a path. Like you don't. Oh my goodness, you don't have a fucking like closed path. For C, D, same thing. You know, A, C, E. There's a closed path. You know, it forms a fucking closed path. Hold on, let me come back to this. Right, so ACE forms a cycle. If you delete any of them, then it is an acycle, like we fucking mentioned before. Right, so yeah, ACE, delete either A, E, or C, then it becomes an acycle. It's not a cycle anymore. ADE, so this is ADE, same thing. If you delete any of them, then it becomes an acycle. BCE, same thing. BDE, same thing. Yeah, you can just see it. Cool. Now, for this part of the questions, part C, it says sketch M as a point line incidence structure. So we don't know what a point line incidence structure is, but I have this nice note that I had on my midterm. Consistent with drawing procedure of point line incidence structure, PLIS, for vectors on Cartesian graph. Of what the fuck am I saying? Of drawing a line that intersects all vectors and noting on the line where each vector intersects with points corresponding to each vector, if that makes any sense. So going back to this, these two examples, if I drew a line here, right, and what's it called? And I just noted where each one of these vectors like kind of like crosses with this line, like so. Imagining this vector C, even though it's not directly intersecting, we just imagine that it fucking shoots out like to infinity, and it does hit it. So we'll have 2 points here, 1, 2, and then 1 here for E, and then 2 here for AB. And just like in the kind of meaning of this kind of like thing, a point line incidence meaning to hit, the structure, we have the exact thing that we drew. We have 2 points here, 1 here, and 1 here. And if you want to learn more about point line incidence structures, this video is too long for me to explain it, but it kind of just tells you, it's a neat way to kind of see the independent sets of the matroid. So if you have like collinear points that are like, so this is in a two-dimensional kind of thing, right? It's because only two. That's not really two-dimensional though. I mean, it is two-dimensional because it's only on this kind of like space, right? We could have drawn it like this, but we didn't. If we have like, actually that'd be probably a better way to draw. I'm fucking rambling, whatever. Part D, sketch the lattice of flats of M. What the fuck does that mean? You know, I was a great student, and for my midterm, I actually made a note. So a subset F inside the ground set E is a flat if the rank of this thing F unioned with X is greater than the rank of just F for any X not in F. Okay, so a flat is a rank maximal subset of the ground set, where if you add any new element to the subset, the rank increases up until you have the whole ground set, in which case you can't add any new elements. That makes pretty logical sense. So our flats with the rank 0 is just the empty set. Flats with the rank 1 are A, B, E, and C, D. So and the flats with the rank 2 are A, B, C, D, E. If that makes sense, because we're just following this definition. So the lattice of flats would look like this. We start from the bottom and then we kind of like go up. This is a nice little like artistic thing. This is why matroid theory is really fucking cool. A, B, E. So we start the empty set, which is rank 0, like we said, and all of these are the same rank, so we put them in the same kind of like rank or whatever, same rung of the ladder. A, B, E, D, E are all here, and then for the final rank we have this, and then we do this nice little lattice of flats. Cool. Holy shit. Our last part is E, write down the bases of M. So we have the bases just meaning, all right, bases meaning that it's the sets of the matroid where if you add any element of the ground set that is not already in the set, so for AC, for example, if you add B, then this set would become dependent. So these sets are the maximally the sets which have elements which if you add any new element to them that are not already in if you add any new element, yeah, sure, then it becomes dependent. So these are the independent sets which are maximally, we can say, independent, right? So AC, AD, AE, BC, BD, BE, CE, DE are all bases because they fucking are. I mean, if you add any element to them, they would become basically dependent, which is not cool. Also note that what the rank means is, so the rank is just a number associated with a set, and that number canonically, so usually, it is associated with the size of the biggest independent set. So like for A, B, C, D, E, the biggest independent set would have size 2, maybe let's say AC, like here. So it is rank 2. And you can't have a bigger rank than 3 because, like we can see here, they all live in a two-dimensional space. So yeah, I mean, it can't fucking, it can't fucking have a size of an independent set which is greater than 2, because if that was true, then the laws of fucking math would just break, and that wouldn't be cool. That would not be cool. So yeah, I think that's the whole problem. If you have any fucking questions, please just ask. It's definitely just on my end. It's not on your end, probably. You probably understood everything. I just fucking did a shit job at explaining everything. I will succeed. And now I will go to a segment where I show my face. Okay, so that was the video. I hope you enjoyed learning about Matroids. Why did if I can even make this video? I think it would just be fun. I thought, it's the summer. I don't really have shit to do. I think it'd be fun to kind of reminisce on my classes that I took last semester in school. Hopefully, I'm gonna be done with school in like a year. I'm gonna be looking back on this video and be like, oh shit. As for me, I want to make more videos. Actually, I want to make like a few more videos before I go back to school. The sprinklers are on because it's fucking 2:20 a.m. My mom's fucking asleep. She's probably hearing me like, what the fuck is this kid fucking saying? In Spanish, obviously. Yeah, I want to make some other videos, maybe about like rockets and shit, explaining like about rocket propulsion. Also maybe a video about like, so I'm training jujitsu. I can't fucking say it. I'm fucking retarded. Jujitsu. And so maybe some videos about like submissions that you can do in jujitsu. I think that'd be pretty cool. Another video about like general relativity maybe would be pretty cool. Abstract algebra would be maybe pretty cool. Quantum mechanics maybe pretty cool. I don't know. I have some, I don't know. This is all for fun. I don't want to fucking just like, the fucking editing's me dog shit too. Like, I think it'd just be cool to just make some videos and post them just for my own enjoyment. Yeah, so hope you enjoyed. Share this with your friends and family, and have a blessed day. Thank you.
Uno, ya. ¿Qué pasó, Maxi? ¿La tierra qué, Maxi? ¡No! ¡Explotó! Tenés cuidado, Maxi. Ten cuidado, ten cuidado, ten cuidado. ¡Palobi! Remanco el Maxi. A ver, déjame fijo. ¡Palobi! Yo también.